There are no blue tigers, no blue bats, no blue squirrels, no blue dogs. Even blue whales aren't that blue. Animals come in pretty much every color, but blue seems to be the rarest. What's cool though is when we do find a blue animal, they're awesome looking. Nature doesn't do halfway with blue. To understand why this is, we're gonna journey through evolution, chemistry, and some very cool physics. But first, we're gonna need to understand why animals are any color at all. And to do that, we need to go look at some butterflies. Because butterflies are awesome, and if you don't think so, you're wrong. This is Bob Robbins. He's curator of Lepidoptera at the National Museum of Natural History in Washington, D.C.
Butterflies are awesome. Make no mistake about it. They're a group of moths that evolved to be active during the day. And if you're active during the day, that means that you have an advantage. You can use light to communicate.
You probably realize this, but out of all insects, butterflies display the brightest and most detailed patterns. And there's a good reason for that. The colors in butterfly wings deliver messages like, I'm toxic, or I'm a male and this is my territory. But not all butterfly colors are created equal. If we zoom way in on a butterfly wing, we see the colors come from tiny scales. It's actually how moths and butterflies get their scientific name. Oranges, reds, yellows, browns, those scales all contain pigments, organic molecules that absorb every color except what we see. Black scales absorb all colors. Animals from butterflies to birds to you and me don't make these pigments from scratch. They're made from ingredients in our diet. You might know this thanks to flamingos. They're born gray, but turn pink thanks to pigments called carotenoids in crustaceans they eat. So when it comes to these colors, you are what you eat, but not so for blue. Blue is different.
If you move the camera, if you can see that the color changes as you move the camera.
It does. It's like a hologram thing.
Yeah. And this is because there's no blue pigment in these butterflies.
Wait, so they're blue, but they're not really blue?
That's correct. Yes.
You're lying to me, butterflies.
These are blue morpho butterflies, maybe the prettiest butterflies of all. I mean, they did make it the butterfly emoji. The blue color isn't from a pigment. The blue comes from the shape of the wing scale itself. And when I learned how this works, it kind of blew my mind. If we zoom way in on a blue wing scale, we see these little ridges. If we slice across the scale and look closer, we see those ridges are shaped like tiny Christmas trees. The arrangement of branches is what gives morpho wings their blue color. When light comes in, some bounces off the top surface, but some light passes into the layer and reflects off the bottom surface. For most colors of light, waves reflecting from the top and bottom will be out of phase. They'll be canceled out, and that light is removed. But blue light has just the right wavelength. The reflected light waves are in sync, and that color makes it to our eye. This hall of mirrors only lets blue light escape. There's even a pigment at the base that absorbs stray red and green light to make the blue even more pure. That's how we get this awesome iridescent blue, the microscopic structure of the wing itself. All of this happens because of the way light bends when it moves from air into another material. So if we fill all those tiny gaps with something other than air, like alcohol, the blue disappears. Technically, this changes the index of refraction, but in plain English, that means blue light is no longer bent the right way. The microscopic light filter is broken until the alcohol evaporates and the color returns. But these butterflies live in the rainforest. You'd think they'd lose their color anytime they got wet, right? Well, watch this. These wing scales are made of a material that's naturally water resistant. They stay blue in any weather. So what about this blue jay feather? If we look through it, the color completely disappears. No blue pigment. Each feather bristle contains light scattering microscopic beads, spaced so everything but blue light is canceled out. Unlike the highly ordered structures we find in butterfly wings, these feather structures are more messy, like a foam. So instead of changing as we move, the color's more even from every direction. Peacock tail feathers, again, it's the shape of the feather, not pigment. But the light reflecting structures here are more ordered, like a crystal, so it's brighter from certain angles. There's even a monkey. Whoa, 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 let's keep this PG. Even that color is made by the adding and subtracting of light waves thanks to structures in the skin. And yes, even your blue eyes are colored by structures, not pigments. Outside of the ocean, almost exclusively, the bluest living things make their colors with microscopic structures, and each one's a little different. No vertebrate, not a single bird or mammal or reptile that we know of, makes a blue pigment on its body. In fact, there's only one known butterfly that's cracked the code for making a true blue pigment.
Blue as a pigment in nature is incredibly rare, but there's one exception so far that we know about, and these are over here called the olive wings. They have evolved a blue pigment, and they're not very common, and we don't know very much about them, and I don't know of any other blue pigments.
That's a really special butterfly. But why is almost all of nature's blue made from structures and not pigments, like everything else? I've asked this question to several scientists that study color, and here's their best theory so far. At some point way back in time, birds and butterflies evolved the ability to see blue light, but they hadn't yet evolved a way to paint their bodies that color. But if they could, it'd be like going from early beetles to Sgt. Pepper's beetles. It meant new opportunities for communicating and survival. Creating some blue pigment out of the blue would have required inventing new chemistry, and there was no way to just add that recipe to their genes. It was much easier for evolution to change the shape of their bodies ever so slightly at the microscopic level and create blue using physics instead. They solved a biology problem with engineering. What I love about this is that these colors have fascinated curious people for hundreds of years. After looking at peacock feathers through one of the first microscopes back in the 1600s, Robert Hooke wrote, "These colors are onely fantastical ones." Even Isaac Newton noticed there was something unusual about these blues, and scientists have been studying them ever since, not only because the science is interesting, but because it's beautiful. Thanks for watching, and stay curious.
Okay.
All right, so you think you're a worse joke than me.
Oh, without any question. I've been doing this a long time.
Okay.
So there was a dance, and the butterfly wasn't there. How come?
There was a dance, but the butterfly wasn't there.
Yeah, it was a mothball.
Oh.
I told you.
Okay, he wins. That was bad.